Welcome to this explainer. Today, we are tracing the incredible journey of India's river systems, moving from their physical geography right up to the high-stakes international treaties that govern them. Whether you're a geography enthusiast or a geopolitical observer, the story of how water flows and how it's managed on the Indian subcontinent is absolutely fascinating. Here's our roadmap for today. First, we'll look at the two systems of Indian rivers, then decoding river drainage patterns, mapping the Mahanadi River, the Great Godavari system, the Indus Waters Treaty, and finally, modern tensions and water politics. Let's get right into it. Section 1, Two Systems of Indian Rivers. To really grasp India's water networks, we've got to start with a basic truth. Not all rivers on the subcontinent are born the same. It's actually a pretty stark contrast. On one hand, you've got the Himalayan rivers. Think of these as the energetic youth. They're fed by melting glaciers, meaning they're perennial. They just keep flowing all year round, carving out these massive catchment areas. But then on the flip side, we have the Peninsular rivers, originating from the plateau and central highlands. These are much older. And here's the kicker. They're non-perennial. Because they rely totally on the monsoon rains, they can actually dry up during certain times of the year, which naturally gives them much smaller basins. Moving on to Section 2, Decoding River Drainage Patterns. Now that we know where they come from, let's look at how they actually move and spread across the landscape. When ancient rivers make their way down from the mountains into the plains, they usually form what's called a dendritic pattern. If you were flying over it, it literally looks like the intricate branches of a giant tree. It's super common in the vast northern plains of India, right? The soft soil there just lets the water fan out beautifully. On the other hand, you have the radial pattern, which is perfectly named. It happens when water starts at a central high point, like a prominent hill or peak, and cascades outward in absolutely every direction. It's kind of like the spokes on a bicycle wheel. We see this a lot in the rugged, varied topography of central India. Section 3, Mapping the Mahanadi River. Let's ground this geography with a real-world example of an old peninsular river. The physical flow of the Mahanadi is actually pretty straightforward to map out. It kicks off its journey right at the Sihawa Mountains, down in the Tamteri region of Chhattisgarh. From there, it makes a steady eastward push, crosses the border into Odisha, and eventually empties out into the Bay of Bengal. And this is a huge deal, because that steady eastward flow makes the Mahanadi an absolute lifeline for agriculture in Odisha. It literally sustains millions. Okay, here's a quick way to lock this basin into your memory. Just visualize the flow. Imagine you're floating right down the river from its start. Over on your left bank, you're joined by the Sionath, the Hasdeo, the Mand, and the Ibe rivers. As you keep going, the right bank throws in the Ong, the Tel, and the Junk rivers. And finally, just before hitting the sea, the Devi River splits off as a distributary. So instead of adding to the main river, it's actually taking water away. Section 4, the Great Godavari System. Now, the Mahanadi is impressive, but things level up and get a lot more expansive when we look at the mighty Godavari, often called the Ganges of the South. Originating over at Trimbakeshwar near Nashik in Maharashtra, the Godavari goes on this grand, sweeping tour of the Indian peninsula. It carves its way right across Maharashtra, flows through Telangana, grazes the borders of Chhattisgarh, and eventually flows out through Andhra Pradesh. It's such a massive network that it even pulls in water from tributaries way out in Odisha. Because it's so huge, here's a brilliant insider tip so you don't get overwhelmed trying to remember it all. Just group the tributaries. For the left bank, think of the acronym DP. That's Dudna and Purna. Then, picture a trishul, a three-pronged trident. That's Panganga, Warda, and Wanganga, which merge to form the Pranhita. Further down, you've got the Indravati and Sabari. Now for the right bank, just remember PM for Pravara and Mula, and MMK for Manjira, Mannar, and Kinnarasani. Grouping them like this takes a really chaotic map and turns it into a perfectly organized blueprint in your head. Section 5, the Indus Waters Treaty. Mastering the internal flow of these rivers brings us to a massive pivot in our explainer. Why? Because rivers don't just politely stop at state lines, they cross international borders. So we really have to ask ourselves, how on earth do nations share a natural resource that completely ignores human-made borders? Think back to the 1947 partition. The British drew political lines, sure, but they couldn't just draw a line through the unified irrigation network of the Indus Basin. The source rivers were sitting right there in India, but the sprawling farmlands that desperately relied on that water were suddenly in Pakistan. It created an immediate, frankly existential friction. Right after partition, they managed this bitter dispute temporarily with a 1948 accord.
but it just wasn't sustainable long-term. Enter David Lilienthal in 1951. He was a former U.S. official who realized, hey, this is an engineering problem, not just a political one. So he suggested bringing the World Bank in to mediate. And over the next 12 years, guided by World Bank President Eugene R. Black, these two nations went from a tense, volatile standoff to a formalized, internationally funded engineering treaty. It was finally signed in Karachi in 1960 by Prime Minister Jawaharlal Nehru and President Ayub Khan.
The real genius, and honestly the major compromise, of the 1960 treaty was its geographical simplicity. Rather than trying to meticulously measure and split up the volume of water flowing down every single day, the World Bank proposed just giving entire rivers to each nation. So the three eastern rivers, the Sutlej, the Beas, and the Ravi, were allocated for exclusive use by India. Meanwhile, the three western rivers, the massive Indus, Jhelum, and Chenab, were allocated to Pakistan. Let's look at the math here. This geographic setup essentially gives India control of about 20% of the total water in the system, while Pakistan gets roughly 80%. But it's important to note it's not a complete lockout for India. India does retain some limited, strictly regulated, non-consumptive rights on those western rivers. Basically, that means they can build run-of-the-river hydroelectric plants, as long as they aren't storing or consuming the water that's meant to flow down to Pakistan.
Section 6. Modern Tensions and Water Politics. For decades, this has been praised as one of the most successful water-sharing agreements ever. But despite making it through multiple wars, this delicate hydrological balance is under intense pressure today.
Following the 2016 Uri attack, geopolitical tensions flared up in a major way. Prime Minister Narendra Modi famously stated that blood and water cannot float together, which signaled a significant shift in posture. Around that time, India actually temporarily suspended the meetings of the Permanent Indus Commission. That's the bilateral body originally created by the treaty to iron out technical issues before they turn into full-blown conflicts. Today, the friction points might sound highly technical, but they are incredibly consequential. On one hand, India is pushing hard to fully utilize its entire 20% allocation, doing things like completing the Shahpur Kandi Dam just this year. On top of that, the Legislative Assembly in Jammu and Kashmir has historically demanded a renegotiation, arguing the treaty unfairly limits their own hydropower and agricultural potential. On the other hand, you have Pakistan's construction of the left bank outfall drain, which has caused flooding and salinity disputes in India's Rann of Kutch region. And both nations find themselves frequently locked in arbitration over the technical specs of Indian hydroelectric plants on western rivers, like the Ganga and Redal projects. The framework is constantly being tested. We have to remember, these aren't just squabbles over blueprints. They represent the food security and the electrical power of hundreds of millions of people on both sides of that border. So, as populations absolutely surge and climate change starts messing with glacial melts and monsoon patterns, we really have to wonder, can this historic 1960 pact adapt to a highly unpredictable future? Or will the flow of these rivers, from the youthful peaks of the Himalayas down to the ancient peninsular plateaus, become the ultimate geopolitical weapon of the 21st century? It is a massive challenge, and one that requires us to really understand both the geography of the rivers and the fragile treaties that try to govern them. Thanks so much for joining me on this explainer. Keep questioning the world around you.